Okay, we're picking up with the second part of 6.2 trig equations. So we had just a little bit of tough stuff with the last example. So we're going to continue to upgrade. That's, y'all know that's just the way examples go. So we got 2 more examples that we're going to work through. So yes, they do upgrade. You can see by the title here, we're fixing to use the quadratic formula with trig functions. So it's going to get fun. This problem right here, the fact that it's equal 1 messes things up. When you see that you have this product over here and it's equal anything but 0, that means you have to multiply all of this out because you have to back up. And then I'm going to take this one, I'm going to move them over. Because your goal is, remember, you can't factor, you can't solve these things. You can't even use the quadratic formula unless you have this thing equal 0. That's your bread and butter. You have to have equal 0. So if you don't have that, there's problems. So you can't leave this broken up over here. So you have to multiply it out, and what's great is if you multiply it out and then you could possibly factor it. This one, however, does not, because there's no 2 numbers that multiply to 1. Oops, I've got an eraser there. That multiply to 1 and subtract to 3. So since this does not factor, we need to proceed with the quadratic formula. So this one's going to have some twists and turns along the way, because we're actually using reciprocal functions. We're talking with cotangent here, so we're going to have some fun here. Remember when we do quadratic formula with x is equal to negative b plus or minus the square root? Okay. Most people go by the x is equal really fast, and they don't really pay a lot of attention to it. But the x is equal, that's your linear term in a squared plus ax squared plus bx plus c. It's right here in the middle. So here in the middle we have cotangent of x. So for us, it's not x equal, it's cotangent of x equals. Then you get to set this up. B squared minus 4ac all over 2a. So I'm just going to write that down just in case you were a little fuzzy on it. Now, fill in your information. Negative b will be a negative 3. Remember, b squared is always positive. A is the number out front. C is the number in the back. Make sure you pick up that negative. Okay, so I've got 2 negatives here. 2 negatives are going to make a positive. 2 times 1 is 2. All right, I need some space. Let's see. That's going to be negative 3 plus or minus square root of 13 over 2. Remember, this is cotangent of x equals. Now, if you're wondering, okay, what do you do with that? That is just a mess. It is time to grab your calculator and quite honestly just turn that into decimals. This is, let's see here, negative 3, open up parentheses, negative 3, and then let's do plus square root 13, arrow over, close parentheses, divide by 2. So I've got 0.3028. Now I'm going to pull that back up, and then I'm going to go in there, and instead of a plus sign, I'm going to put a subtraction sign so I can get the other version. And there we go. So here are my 2 answer options. That was the positive version right here, and this is the negative version right there. Now, I need to actually work these as separate problems. So I guess what would be wise is to not write them like this. Let me show a little wisdom here. Let's take this second one and write them like this. There we go. Now we got our 2 separate problems. That looks a little bit better. Okay, now just like the other problems we've been doing, We have 2 to solve. Now the understanding here is, since we've got crazy decimals, we're working in radians. So keep your calculator in radians. Here we go. I don't have a cotangent button on my calculator. I need to go with reciprocals. So the reciprocal of cotangent is tangent. Well, to do the reciprocal over here, you literally do the reciprocal. Now, I have tangent and I have a positive fraction. Which 2 quadrants is tangent positive in? 1 and 3. Okay. Well, make sure your calculator's still in radians. And then we're going to do inverse tangent. 1 divided by 0.3028. And that gives me a reference angle of 1.2768. Now I wrote it down as an answer because in quad 1, that is my angle. Now I need to find out what that angle plus pi is. Because remember pi and 180 right here? I need to swing past it, that angle. So let me take that and I'm going to add pi to it. And when I do that, I get it to be 4.4184. So I have 2 answers from that. Okay, same thing over here. I've got to do reciprocal. All right, on this one, I need reciprocal. Now, don't lose your negative now. Negative's important. It doesn't really matter where you put the negative. You can put the negative in the top, you can put it out front, you can put it in the bottom, just don't lose it. And remember, what is the negative good for? Placement. Tangent is negative where? Second, fourth. That's all it's good for. Your negative is not going in your calculator. You're fixing to type second tangent positive 1 divided by positive 3.3028. That's going to give me my reference angle, which is 0.29, and quite honestly, you just round it up to this. That's my reference angle. But I need that located in second quadrant. So we need to do pi minus that answer. So I got 2.8476. All right, and now I need to do fourth quadrant. That would be 2 pi minus 0.2940. All right, this one is 5.9892. All right, so got some very bizarre looking answers, but those are correct. That's just how those work, as weird as that may seem. That's what we need. So hang in there, practice with them, and let's look at the next one. We've got one more example problem that we need to work with. Again, they stipulate radians. And here's our problem. Hopefully you notice off the bat that we have an issue. They're not the same trig function. Now, if you remember, a couple of units ago, you were given a relationship between tangent and secant, or actually between tangent squared and secant squared. Remember that lovely Pythagorean relationship? Well, now you can't right now go through and do any substitution because these aren't squared. You have to have it squared before you can use this thing. So, with that in mind, you can square both sides. So that's secant squared x, and if you square this binomial, remember it's square the first, twice the product, which means you're going to multiply these together and put a 2 on front. And then you're going to square the last, which means when you square the square root of 3, you just get 3. Now, notice, I have tangent squared, I have regular tangent, and I have secant squared. If I'm going to try to get this thing to where it's all the same function, do I need to substitute for tangent squared, or do I need to substitute for secant squared? Now, I'm hoping you're saying that you're substituting for secant squared, because there ain't squat you can do for tangent. you're stuck with regular old tangent. So we need everybody with tangents. Let's pull a switcheroo on secant squared. Instead of him, we're going to write 1 plus tangent squared x. Now, so let's just copy. Tangent squared x plus 2 square root of 3 tangent x plus 3. Now, all this is from here on out, it's pretty sweet. You're just solving an equation. Do you see that there's a tangent squared on either side? Well, they cancel. Now, if you subtract 3, because that's just a constant term, I have 2 square root of 3 tangent equals negative 2. Divide by 2 square root of 3, because this is just the value in front of tangent, right? You can do that. You can't touch anything in front of the x, in front of your angle, but you can do it in front of the trig function. Now, so these go. I have tangent of x equals, now think about it, over here, the 2's cancel. So I have a negative 1 over square root of 3. So all of that mess reduced very nicely. Same thing we've been doing. The negative is for placement. Tangent is negative in 2 and 4. And let's think. That just might work. Opposite, adjacent. And that would be negative. Which angle is that? That's 30 degrees, isn't it? So if that's 30 degrees, that's the same thing as pi over 6. Is that right? Because I'm needing radians, right? And this is pi. So from, remember, whatever your denominator is, that's 6 pi over 6. Take 1 off. 5 pi over 6. Double him. 12 pi over 6, right? Take 1 off. 11 pi over 6. There you go. If you don't like that, remember, you can go through and you could think in degrees. You could say, oh, that's 150 and that's 330. And then you can take both of those and multiply them by pi over 180. And they should reduce out to your radian equivalencies over here. Okay? All right, y'all work on your homework. Practice up, because the next section in trig equations takes us into double angles and half angles and stuff like that. So you want to make sure you've got this down good before you venture into that.